In this video, we're going to learn how to factor binomials or two terms, and we're going to look at difference of squares, difference of cubes, and sum of cubes. So we'll start with the formula for difference of squares. So this is the general formula here. And we want to use this formula to factor. So difference of squares means that we have two squares and we have a subtraction sign between them. And if you have a situation like this, it will factor into two binomials where the only difference is that they have opposite signs. And so you can actually also write, because the order doesn't matter, we can also write x plus y first and x minus y second. So we want to use this formula to factor. So we have 4 examples. We want to factor completely. For any factoring problem, if there is a greatest common factor, we always want to factor that out first. Notice in the first example, we have a greatest common factor of 5, and so that needs to be factored out first before we apply this formula. And so the first step is just to factor out 5. Then we focus on whatever is inside of the parentheses. Our GCF just carries down. Notice that in order to use the formula for difference of two squares, you have to have a difference. If you have a sum, then we do not use this formula. So this is a difference, and then we have x squared, and then we look at the number 9. 9 is a perfect square. It's 3 times 3. And so this is a difference of squares, and we can apply this formula. And so we basically write 2 parentheses, and remember, you should have x times x. We always have opposite signs. It doesn't matter which sign you write first. And then 9 is the perfect square, so we write 3 and 3. And that is completely factored. The second example, again, just a quick check to make sure that this is a difference of two squares. So we have a difference. 49 is 7 times 7, and 1 is also a perfect square because that's 1 times 1. There is no GCF in this case, so we write 2 parentheses directly, and you're going to write this as 7y, 7y, and then again opposite signs, and 1 and 1. Notice that if you were to FOIL, you would get back to the original problem, so you can check your work that way. Example 3, we just want to, again, quick check, make sure you have a difference of two squares. So we do have a difference. The first part, this is squared, and also 121 is 11 times 11, so that is a perfect square, and I can apply the formula up here. No GCF, so write 2 parentheses, and this should break up into x times x, x times x, opposite signs, and 11 and 11. Number 4, we have a difference. You have x to the 4th. So this is a little different because the exponent is 4. It's not 2. But we can still factor this as a difference of two squares. 16 is a perfect square. 4 times 4. So let's see. 2 parentheses. We could break up x to the 4th as x squared times x squared. So that works. Opposite signs. And then 16 is 4 and 4. Now this is a little bit different because if you look at this carefully, it is not completely factored. Take a look at x squared minus 4. This right here is another difference of squares. So we can continue factoring this second part. And so there's one more step to get to the final answer. X squared plus 4 we can't factor. This is not a difference of squares, and so this just carries over, carries down, and then we're going to factor this part, And so we have x and x, opposite signs. And so now this is completely factored. This will be our answer. There will be problems where you need to do more than one factoring step. So always look at what you get once you factor and see if you could continue factoring. So in this case, we were able to continue factoring because we had another difference of 2 squares. Let's take a look at the second part where we look at difference of cubes and sum of cubes. So there is a formula for each of those. So we have our formula for difference of 2 cubes. So cubes just means that you have an exponent of 3. And so you can have a difference or a sum. The formulas are very similar. So we want to look at how to remember this in an easy way. So one way to do this is if you have a difference or a sum, the first parentheses is a binomial. And so if you have a difference, then essentially you just write x minus y, where we don't look at the 3's. So basically just remove the exponent 3 and just write x minus y. The same thing here. This is a sum, so we write x plus y without the exponent. And then the second parentheses, what you're going to do is remember that this is a trinomial in both cases. And we can look at the first part here. This says x, so you're going to square the first term. These two should be opposite signs. And then you need to multiply x and y without the sign. Just multiply x and y, so we get xy. And then you're going to square that last term, so we get y squared. Notice that the second sign is always positive in both cases. For the sum formula, it's the same pattern, but remember these have to be opposite signs. So let's take a look at the 3 examples I have listed, and we're going to apply one of these formulas. Always remember that if you see a greatest common factor, that should be factored out first. So number 1 actually has a greatest common factor. The GCF is 4. So I have that, and then what you want to do is focus on whatever's in the parentheses. You can do an extra step if you want. You can write this as x cubed plus 2 cubed. That way you see the terms that are cubed, and then we can apply the second formula for sum of cubes. So remember that the first part is a binomial, so basically we just copy what we have here but without the exponents. The second part is always a trinomial, and to get the second part we just focus on x plus 2. You're going to square that first term, so that makes it x squared. Should be the opposite sign of whatever is here, which in this case is minus. Then we multiply x and 2 together, we get 2x. The last sign is always positive, and you have to square the last term. And this is now completely factored. We cannot factor the trinomial. And so that is the pattern for these problems. Let's take a look at the second example. And so notice that that is a difference of cubes. And so we have a difference, and we also have 2 different variables. So 125, you might want to do this step, is 5 to the third times a to the third minus 216 is 6 to the third, b to the third. If you write it this way, then it might be easier to apply the formula. So we're applying the first formula. So the first part, you write whatever you have here, but without the exponents. 5a minus 6b. And then the second part, you're going to square the first term. I have to square 5 and square a. So that's 25a squared. Opposite sign of minus, which is plus, multiply these two together but without the sign, so that's 30ab, plus square the last term, so square 6, square b, and that is the complete answer. Last example, I'm going to do the same thing. There's no GCF, so I just write everything with an exponent of 3. 64 is 4 to the third. And then we just write two parentheses. The first one should be xy minus 4. And then the second one, square the first term. X squared, y squared, opposite sign, multiply 4xy, plus square the last term, 16. And that is our last example.